Hey guys, welcome back to the channel. If it's your first time here, we go through math and physics tutorials, as well as how to improve the mindset of a student. In this video, we're going over the unit circle, special triangles, and why some angles are positive or negative in certain quadrants. By the end of this video, you'll be able to construct and interpret the unit circle, as well as have a strategy to remember the special triangles and whether angles are positive or negative in certain quadrants. This will be part number 1 of a 2-part series related to the unit circle, and in the next video, we'll go over the same concepts here, but in radians. If you find this video helpful, I'd really appreciate you liking this video and subscribing to the channel to see more videos just like this. At the end of this video, we'll talk about why teaching is the most effective way to study and how it can change your behavior and psychology towards the subject. Alright, so here I have a unit circle, and what a unit circle is a circle that has a radius of 1, so 1 unit. And this circle was drawn at the origin, so at this point here it's 0, 0. So if it has a radius of 1, if I just go along the x-axis, this point here will be 1, 0. If I go along the y-axis, it'll be 0, 1. And similarly, if I go in the negative x and negative y direction, I'll get similar values. So I'll get, in this way, it'll be negative 1, 0. And over here, it will be 0, 0, -1. So now I'm going to draw an angle that touches a point on this circle. So I'm going to draw an angle like this, and it's going to touch this green point up here. Now, just like we have a positive sign convention for things in the x direction towards the right, so if we look at this value here, that's positive 1 because we went to the right, and if we look over here, that's the y-coordinate is positive 1. We've just defined that as a sign convention to be positive and negative. We could have gone to the left or we could have gone to the right, but typically the right means positive and up means positive. But there's also a rotation sign convention. So here, I rotated this way, an angle theta, and that is positive. So counterclockwise is a positive sign convention for angles. Now that I've drawn this line, this point here I'm just going to say is A, B. So in the x direction it's an A distance, and in the y direction it's a B distance. That's A and B right there. So now what I'm going to do is I'm going to draw a right triangle from this point and this angle. So I'm just going to bring this down right here, and I'm going to say that from this distance to this distance, that is A. And that's what we said here because A was representing our x coordinate. Obviously a point is represented by x, y. So here, this blue line is the distance in the x direction that gives us the A point. Now in similar fashion, I'm going to draw another dotted line. This will be in yellow, and this is representing the y direction. So this distance here is representing the B component of our point because it touches that component there. So in this situation, we now have a triangle that's represented by side lengths A, B, and because it's a unit circle, this line right here has a length of 1. Now I'm going to write out all the formulas that we have using SOHCAHTOA. So that's sine, cos, and tangent. So we have sine of theta is equal to, well, so it's opposite over hypotenuse. That's what the h is. And then cos of theta would be adjacent over hypotenuse. And finally, tan of theta would be opposite over adjacent. So using this angle of theta and the side lengths that we've defined of this triangle of A, B, and that 1, I'm going to rewrite some of our side lengths in terms of our angle. So I'm going to say that for sine of theta, and I'll do it in yellow, I'll say sine of theta is equal to the opposite angle over the hypotenuse. So here, our opposite angle is actually just this height here, B. We drew it on this side here, but it can be moved over here. And now we can say that sine of theta is equal to, well, that's just the side length B, and then divided by our hypotenuse. Well, our hypotenuse is just 1. So I can say that B is now equal to sine of theta, because if we multiply both sides by 1, like this side of the equation and this side of the equation, we'll get B is equal to sine theta. Now I'm going to do the same process, but now for cos of theta. So I'm going to say that, I'm going to do it in blue, cos of theta is equal to adjacent over hypotenuse. And in this case, if we use our theta we've defined here, our adjacent side is just a, and our hypotenuse is still 1 because it's the radius of the unit circle. So now I'll get a is equal to cos of theta. So when I first defined this point on the unit circle, this point a comma b, I talked about how a represented the x direction, or the distance in the x direction, and b represented the y direction, or the distance in the y direction. Now I've come up with kind of two new expressions for a and b. But the first expression of b being the y coordinate still holds. So I can say that sine theta is the y direction, and cos theta is the x direction. Now with that knowledge, I can now rewrite our a comma b point as, well, a is represented by, let's see, cos theta. So I can write a over here as cos theta and b as sine theta. So because of this derivation we've gone through, I can now express the a comma b point in terms of the angle it's at. Alright, so the reason why the sine theta and cos theta for the x and y directions are so important is it tells us where things are negative, where the angle would be negative. So if I draw an angle like this, in this quadrant over here, and say, we'll call this right here, this angle is theta. So if we now say that the cos theta is our direction, and our sine theta is our y direction, we can say that this angle is going to have a negative x direction, so kind of a negative cos theta, if that makes sense, and a positive y direction, because we're going over here, this would be the negative x direction. And here would still be the positive y direction. There's a bunch of different acronyms to remember where angles are positive and negative, and whether sine or cos or tan actually creates a negative or positive angle. And what they are all students take calculus. There's also all students take crack, depending on how politically correct you are. There's also cast, so starting from here and going around like this. C-A-S-T would be cast. I usually don't go with that kind of logic, or I guess memorizing those things. I just want to really hammer home that the x direction is cos theta and the y direction is sine theta, based on our unit circle derivation. So now you can see that, well, sine here, if we look at this angle, there's kind of a reference angle here, so we'll call that phi. So sine of that angle phi is going to equal, well, here we're going in the positive direction, so we're going in the positive y direction, which sine theta is represented by. So if I have a value of like b over here, I can say that b over hypotenuse, which is our length here, now our sine of phi is going to be positive. And the reason is because we're going in the positive y direction, and our hypotenuse is positive. So this angle here, or I guess this angle in here, is going to be positive. And similarly, if I have an angle in the third quadrant here, so if I draw an angle like this, and we say the angle is like that, that is theta. So here, we're moving in the negative x direction because we're over in this quadrant, so this would be negative x, and we're also moving in the negative y direction. So in this case, both sine and cos are going to be negative because, again, if I use this reference angle here of phi and draw kind of a right angle triangle, here, well, this is going to be negative b, let's call it, and then over here, I'll do it in that blue to stay consistent. And then here, we're going to have negative a. So again, if we do sine of phi, that's going to equal negative b over our hypotenuse, and in this, it's going to be 1 here, just because we don't have any other numbers. So this angle is going to be negative. Now if I do it with cos, we have is equal to negative a over our hypotenuse, so which is 1. So again, we're going to get a negative angle. And the tan here, well, tan of phi would be sine of phi, or opposite over adjacent. So sine of phi over cos of phi is also equal to opposite over adjacent. So here, we could either use our values of our angle for and plug them into this expression. Or we could just use our side lengths. So we could say tan of phi is equal to, well, it's going to be negative b over negative a. And a negative over a negative is going to be a positive. So we now know that this quadrant, tan is positive. And again, if we use our acronyms, that lines up, because this is the tan quadrant. So now we're going into special triangles, and special triangles are basically just patterns of side lengths and angles that save you time and can get you an answer very quickly using the trigonometric functions. The way I kind of remember our special triangles is I draw a square of side length 1, and then I draw a diagonal through that. So once I draw a diagonal through that, what's going to happen is this 90-degree angle is now going to be cut in half, and this will be 45 degrees, and this over here will be 45 degrees. This is still 90 degrees, so again, 90 plus 45 plus 45, going to be 180 because it's a triangle. And then now we can just do Pythagorean theorem, so it's going to be a squared, we'll put this as a, this is b, so a squared plus b squared is equal to c squared. And here, we're going to get c is equal to 1 squared, or I guess I'll do, so 1 squared plus 1 squared, c squared will equal 2 squared, and then if we square root it, it'll be root 2. So here will be root 2. And that's the first special triangle. For the next special triangle, I draw a equilateral triangle, so side length 2, and side length 2. And because of that, all the angles are going to be the same as well in this triangle. And then I'm going to cut this angle in half. So here is now going to be a right angle, and this angle in here is now 60 divided by 2, so it's going to be 30 degrees. Now, and because we cut this in half, this side length now is 1. So now, again, we can use Pythagorean theorem where this is our hypotenuse and this is the side length. So we can do a squared plus b squared is equal to c squared. And we don't have 1 on our side, so I'll say our a is equal to 1, and we don't know our b. So we're going to do 1 squared plus b squared is equal to 2 squared. And if I do that again, or if I isolate b, it's going to be 2 squared minus 1 squared. B squared is going to be, well, that's going to be 3 right there. It's going to be 2 squared is 4, and then minus 1 squared is just 1. It's going to be 3. So then b is going to equal root 3, and that is this value right there. So now we have all these triangles where we have a sine, or a 60-degree angle, a 30-degree angle, and a 45-degree angle. So we have, I'll say that again, a 30-degree angle here, a 60-degree angle here, and a 45-degree angle. So now we know whenever we have a sine or a right triangle that has one of these angles, we can quickly draw these kind of shapes and find these angles to give us our values. So now if I said, what's sine of 60? Well, you know that that angle is right here, so it's going to be opposite over hypotenuse. So it's going to be root 3 over 2, because this is the opposite side and this is the hypotenuse. I could also say, what's cos of 45? And then you could jump to this triangle here and say, well, it's going to be, I can either take either angle, doesn't matter, and I'll say, okay, well, it's going to be a over our hypotenuse, which is 1 over root 2. Finally, if I said, what is tangent of 30 degrees? Well, you'd say, okay, well, tangent, well, the opposite side is 1, and then divided by our adjacent side, and our adjacent side would be root 3. So now we have a quick way of evaluating angles that are going to come up a lot, the 60, the 30, and the 45, and we can easily find what these angles are and they evaluate them by not even plugging it into a calculator, by just using these special triangles. Okay, so now we're going to be asked to evaluate what sine of 150 degrees is. I'll put a degree symbol in there. So I've drawn this angle, and because we know that this is 0 degrees, up here is 90 degrees, because this would be a right angle. This would be 180 degrees, and this would be 270 degrees. And if we went full circle all the way around, it'd also be 360 degrees. So we can use this knowledge of each of these values at each axis to find the angle we're looking for. So here we could say, well, if from this line, I'll do it in orange, from this line to this line is 180 degrees, that means that 180 minus our 150 is going to give us this yellow angle, which would be 30 degrees. And here, again, I don't have to use a calculator here. I can draw this right triangle and evaluate this value by using our x and y coordinates and seeing where they're positive, as well as using our special triangles. So again, I'll draw the equilateral triangle, and we're going to say that this is 60 degrees in here, this is also 60 degrees, and this is 60 degrees. They each have side length 2. Now if I cut it in half and draw something like that, I know that this angle is now going to be 30 degrees. Over here is a right angle, and if we do Pythagorean theorem, I'm going to get root 3 on this side. So now we can say that, well, let's look. So sine of 30, or sine of 150, we're saying sine, well, this is the positive y direction here. This is positive. And then we have sine of 30 using this special triangle. Well, this side length here is 1. So we could say that the sine of 150 degrees is going to be positive because of its opposite side is the y direction and it's positive, and it's going to be 1 over our hypotenuse. So sine of 150 degrees is going to be 1 over 2. And if we would evaluate that in our calculator, we get the same answer. Alright, now our example is, what is the cosine of 240 degrees? So here I've drawn another angle of 240 degrees, again, because this is 0 degrees, this is 90 degrees, this is 180 degrees, and this is 270 degrees, as well as a full revolution would be a 360 degree angle. And here I can say, well, 180 minus 240, or I guess 240 minus 180, this angle in here is going to be 60 degrees. And then again, I'm going to draw my right triangle, and I'm going to say this is 90 degrees, this has to be 30 degrees. So if I look at our right triangle, or our special triangle, again, I'll draw an equilateral triangle with 60 degrees, side length 2, and I'll cut this in half. Now I'll get, using Pythagorean theorem, that our side lengths are 1, 2, and root 3. And again, I encourage you to go through these special triangles every single time, because that's what's going to make it second nature. You could memorize it by just looking at the unit circle, but what's going to happen is you might second guess yourself on a test, or you're not going to really be convinced of it. But if you use this process of always just building the triangle and then cutting it up, you go through more of a concept as opposed to like memorizing facts or memorizing different things. You'll find that after you do this a couple times, it'll be a lot easier to remember, and it's more intuitive if you've already proven it to yourself. So now I can say that this angle in here is 30 degrees. And what are we doing? Well, we're doing, this should be, if we're doing 60 degrees, this should be 30 degrees. And now if we're doing the cosine of 240, it's going to be equivalent to the cosine of 60 degrees. And let's think about this. So the cosine of this angle, well, we're going in the negative x direction. So over here is negative x. So we're going in the negative x direction. And cosine of theta is the x direction. So we're going to have negative x direction over a hypotenuse. That's going to give us a negative value. Again, it will follow that all students take crack kind of acronym. But we can also prove it to ourselves by saying that we're going in the negative x direction. We know that cos theta is responsible for x coordinates, or x direction. And now we know that this cos angle is going to be negative, which would make sense because here only tan is positive and both sine and cos are negative. So we can look at our special triangle and we can say, well, cos of 60 degrees, that's going to be adjacent over a hypotenuse. So 1 over 2. So we're going to get cos of 240 degrees is going to be negative, because it's negative 1 over 2. So that would be our answer to this expression and this angle. Okay, so for our last example, we have tan of negative 45 degrees. And what I said before of evaluating, or I guess defining a positive sign convention for angles is really important. So again, just like we go right and we say that's positive in the x direction, and we go up and that's positive in the y direction, our rotational positive sign convention is counterclockwise. So when they say negative 45 degrees, we're going in the clockwise direction. We're going this way instead of that way, which would be positive. So now to evaluate this, I know that, well, tan is going to be opposite over adjacent. So here, we're going in the negative direction. So this is in blue, actually yellow. We're going in the negative y direction. We're going this way, negative y. And then we're going in the positive x direction. So that's going to be x over here. And if tan is opposite over adjacent, we're going to get that tan of negative 45 degrees is going to equal, well, that's going to be x on top, or negative y on top over x. So we're going to get that tan of negative 45 degrees is going to give us a negative value. And that again makes sense because we have this cast rule. And here it says that cosine is only positive in this quadrant. So tan is going to be negative. Now I can use our special triangles, and for this one it's going to be our 45 degree. So we have a square that's all side lengths of 1. Then I'm going to draw a diagonal through that. And we before had 90-degree angles. Well, when I cut it in half with a diagonal, now we're going to get 45-degree angles. Again, using Pythagorean theorem, this value up here is going to be root 2. So now we can say, okay, tan of 45 degrees, well, that's just 1 over 1, because it's going to be the opposite side over the adjacent side. So tan of 45 degrees is equal to 1. And we also have that this is a negative angle, right? We knew that it was going to be negative in this quadrant. So tan of negative 45 degrees is equal to negative 1. So as I've mentioned in previous videos, teaching others is a form of active learning, where active learning is actually applying yourself, doing the problem, it's making notes, whereas passive learning would be listening to a lecture or reading those notes. Active learning always has higher retention or leads to higher retention rates versus passive learning. This makes it a more effective and efficient way to study if you use active methods versus passive methods. And teaching of the active methods has been proven to lead to the highest retention rate. As an added bonus, it's been shown that teaching actually provides more motivation for the teacher and leads to behavioral and psychological changes. So you now as a teacher need to know the concepts really well and know the content extremely well to be able to communicate and articulate it effectively. And now you need to be the example of those that you teach on how to study the subject and how to become successful at that subject. This is why teaching is such an important and effective tool and is honestly invaluable study method for your academic career. So to put this in practice, try teaching a family member, whether that be a parent who hasn't touched the concepts in a while, or a younger sibling or a younger cousin. Teach them what they're struggling with, or teach them what you're learning right now. Also, don't be afraid if you have to go back a few years. Say you're in grade 12 and you need to teach your grade 10 cousin something about like quadratics. Don't feel like that's a step backwards. In all honesty, you'll find that you'll learn just as much as they will while teaching the concept. A lot of the time when I've kind of gone back to learn something that I've learned previously, I've caught things that I hadn't seen the time before, and it makes things a lot easier, especially in math and physics. So much of it is built at a foundational level that going backwards or going into previous year's studies isn't going backwards. You'll get just as much value out of it, and you'll see concepts you didn't see the first time. Thank you for taking the time to watch this video. If you guys like this content, please like this video and subscribe to the channel to see more videos just like this. I make a ton of content in high school math and physics, as well as improve the confidence and mindset of students. If you have a specific topic you want me to cover, let me know in the comments down below. Thanks again, and I'll see you guys in the next video.